You've probably seen the headlines, right? These absolutely catastrophic flash floods and landslides that have been sweeping through communities, especially this monsoon season. It just feels so sudden, so violent. So what's actually causing it? Well, today we're going to unpack the science behind a really powerful and, frankly, destructive weather event, the cloudburst.
All right, so here's how we're going to break this down. First, we'll look at the sheer scale of the recent devastation. Then, we'll get into the science, the actual recipe for a cloudburst. After that, we'll explore the human fingerprints on all this, why mountains are such a critical factor, and finally, we'll tackle the huge challenge of trying to predict these things.
So first up, a deluge of destruction. And listen, this isn't some abstract weather term. This is a crisis that's unfolding right now, and it's what's putting the word cloudburst into such sharp and tragic focus for all of us.
So what even is a cloudburst? It's not just heavy rain. It has a really specific and pretty intense definition. We're talking about more than 100 millimeters, that's almost 4 inches, of rain falling in just 1 hour over a pretty small concentrated area. I mean, just try to imagine that volume of water coming down all at once. It's incredible.
And the consequences of that much water, well, they're just devastating. This monsoon season alone, these major cloudbursts across parts of India and Pakistan have led to the deaths of hundreds of people. And they've forced thousands and thousands more to flee their homes. This is the real human cost of these extreme weather events.
So that brings us to our next question. How does something like this even happen? This is section 2, the cloudburst recipe. It's all about how the atmosphere cooks up such a violent storm. And it turns out it's a very specific combination of ingredients.
You can think of it as this simple but incredibly powerful 3-step process. Okay, so first, you have these warm, moisture-packed monsoon winds traveling in from the sea. Step 2, as these winds get pushed up over the huge mountains in South Asia, they slam into much colder air. And that collision, that's the trigger. That's step 3. It causes this incredibly rapid condensation process that just wrings out all that moisture at once, unleashing it in one massive downpour.
But, that natural recipe, that's only part of the story. And this is where it gets complicated. So now we're at section 3, the human fingerprints. Because our actions, well, they aren't just contributing to the problem, they're actively making it way more dangerous.
The first big factor here is just a warmer planet. It's basic physics, really. Hotter air can hold more moisture. The best way to think about it is like the atmosphere is a giant sponge. As we heat up the planet, we're making that sponge bigger and bigger, letting it soak up way more water, which is then ready to be released in one of these extreme downpours.
The second huge factor is deforestation. See, when we clear forests, that bare, exposed land heats up much, much faster than land covered with trees. This superheated air shoots upwards really fast, and when it collides with those cool, moist monsoon winds, bam! You've created the absolute perfect conditions for the kind of violent updrafts that fuel a cloudburst.
And this really gets to the heart of how crucial our forests are. There's this quote from the source material that puts it perfectly. Trees and forests are our frontline soldiers in this fight. They are our natural defense against the damage from flash floods.
So how do they actually do that? Well, for starters, the leaves in the canopy, they act like a giant umbrella, breaking the speed of the raindrops. Then, the root systems, they create these little channels in the soil, helping the ground absorb incredible amounts of water, just like a sponge. All of this massively reduces that dangerous runoff. And get this, in the Himalayas, forests even help keep the region's glaciers cool. They do so much.
Which brings us to our 4th section, why mountains matter. Because it's not just about how much rain falls, it's about where it falls. The landscape, the topography itself, can turn what is already heavy rain into an actual weapon.
Yeah, this is where geography becomes so incredibly critical. Look, if a cloudburst happens over flat plains, all that water has a chance to spread out, The impact is much less severe. But in the mountains, that same amount of water gets funneled into these steep, narrow valleys. It becomes this concentrated, super destructive force, and that is what triggers the catastrophic flash floods and landslides that we've all been seeing.
So all of this leads to a really critical question. And that brings us to our final section today, forecasting the storm. If these events are so localized, so dangerous, can we even see them coming?
I mean, given how destructive they are, being able to predict a cloudburst would be an absolute game changer, right? With all the advanced technology we have today, you'd think the answer would be a simple yes, but it's way more complicated than that.
This really breaks it down. Trying to predict the cloudburst days in advance, right now, that's pretty much impossible. Okay, what about the short term, say a few hours out? Well, Doppler radar can spot the buildup of really dense clouds, and it can issue a warning for a general area. But, and this is the absolute key, pinpointing the exact spot where that cloud is going to burst, we just can't do it yet.
That being said, there's a lot of work being done to try and close this gap. India's weather department, for instance, is in the middle of installing a whole network of new, more advanced radars all across the Himalayas. The goal here is to seriously beef up their monitoring and improve those critical early warnings for the communities that are most at risk.
And that kind of leaves us with one final thought-provoking question. As we race to develop better and better technology to predict these storms, should we also be looking back to nature? After all the data and all the science, maybe our most effective, our most sustainable defense isn't just found in radars, but in roots.